All right, folks, it's back in action here. In this video, we're going to look at the last two shapes that we're going to study for our polar graphs. There are more shapes in the world of polar graphs, but these are the last two that we're going to study. We're going to look at lemniscates and roses, and I'm going to start with the roses here. We have two major categories of roses, roses that have odd petals and roses that have even petals. Their equations are going to look slightly different, but first I want you guys to notice a few things that are similar between them, okay? First of all, they're going to have a coefficient, and that coefficient is going to tell you how long the petal is, okay? So when we look at these two graphs, it's going to be how long the petal is on the graph. The other thing that I want you to notice is that the cosine and the sine in the two equations is still going to impact its symmetry. For the roses with odd petals, the cosine and sine is going to follow the same pattern that we've been looking at up until now. Cosine will have polar axis symmetry, the sine will have the pi/2 symmetry. But on roses that have even petals, the sine and the cosine are actually going to behave the same, and both forms will have all three types of symmetries. So really, it's the odd petals that you need to be paying the most attention to. Now that we know the petal length, the other thing is how we would determine whether or not the graph would have a number of odd petals or even. And that's going to be based on this n value that is inside the sine or the cosine. That's going to be multiplied by our theta. If that n value is odd, then it will have that number of petals. So whatever the odd number is tells you the number of petals that you have. If the n value is even, then the number of petals is actually going to be double that, okay? So using these ideas, we can actually now introduce the idea of working backwards from a graph. So if I look, for example, at this first rose that I have here, I can see that I have 5 petals, so it's odd, and I can also see the length of my petal is 3. So I can write a couple things immediately. I can say R equals, and I know I'm going to have a length of the petal is 3. And I can see that this odd petaled rose is oriented along the pi/2, so that would mean that it's going to be a sine. And since it was odd petals, 5 of them, then the n value in the equation is the same number of petals, so I can just write 5 theta. And that equation right there is in fact the equation for this rose. Now on that even petaled rose, I'm going to have my R value. I'm going to have R again. And when I count up the number of petals, 1, 2, 3, 4, 5, 6, 7, 8, I have 8 petals, which means in the equation, I only need a 4. And then I can also see that the length of my petal is 4. So the petal length is 4. And then I'm going to go ahead, I'm going to write this one as a cosine. And then I'm going to write 4 theta. Okay, so that's going to be my, my equation for this one. Now, the last one we're going to have is a lemniscate. And the reason the lemniscates and the roses are together is because the way that we can identify that we're going to have a lemniscate is that this will always be an R squared, and this will always be a 2 theta. So really what ends up happening with the lemniscate, this little figure 8 here, it's essentially that 2 is an even number, so it's essentially a 4-petal rose, but these petals that would have ended up out here and like the negative petals get, you know, wrapped up inside the other 2 when we square it. And don't worry so much like if you can't quite visualize what that's going to look like, but just know that on these lemniscates, they really only come in 2 forms. If it's a cosine, the graph will always be oriented along the polar axis. We're going to graph one down below in a minute, but it's going to actually just be right along the polar axis there. And if the equation is a sine, it will always be that figure 8 rotated at 45 degrees, always. Now, the last thing that we do want to be careful with is this petal length here. And we want to notice that instead of the coefficient just being the length of the petal, it's actually going to be the petal length squared. So we need to be a little bit more careful on that. So this lemniscate, for example, the equation for this one is an r squared, and this was actually, its coefficient was a 5. So when I did the square root of that 5, I got something a little more than 2. That's why this right here, if you want to write it, that petal length is actually the square root of 5. And I can see it's rotated on the 45 degrees, so this had to be a sine, and this is always going to be a 2 theta. And you can see that I've summarized its symmetry down here. When it's cosine, since it's oriented along this polar axis, it's going to have all of our symmetries, but the sine will only have symmetry around pole. Now, graphing the roses is sometimes a little bit more complicated, especially when we have a leading coefficient on that rose that is a negative. That's going to often make things a little bit weird for us. So I want to go through these steps, and the more you just keep these steps in mind, the easier graphing a rose is going to be for you. So I can recognize this as a rose because what I have inside following the trig function is not just a theta. That's a big clue for me there. So I know that this one's going to be a rose. I can see that my value inside is odd. So I'm going to have 3 petals. I'm going to write the 3 right there, I'm sorry. And then the petal spacing is how far apart the tips of them should be. So that's actually going to take the whole circle, 360. You could use 2 pi, and I'm going to divide that by how many petals I have. So my petals need to be 120 degrees apart. You could, of course, do that as a 2 pi over 3 as well, if you prefer that. So what I've got here is 3 petals. Each petal needs to be 120 degrees apart, but I need to know where to start the first petal before I start spacing them apart. So what we're going to do is we're going to look at our sine and our cosine. So if the equation is in terms of sine, which ours is, what we're trying to think about is where does sine equal 1? Well, I know that sine of 90 equals 1, and I know that cosine of 0 equals 1. Those are the 2 values that we're going to regularly come back to. The equation we're currently working with is a sine, so we're going to use this piece of information to help us. Since sine equals 1, that's where our longest petal is going to be, so we're going to use that 90 degrees. And we're going to divide that by our number of petals. And that's going to tell us that at 30 degrees is where we should start the first one. Now, if this seems confusing to you, what I want you to do is I want you to pause the video, and I want you to take this 30 degrees and imagine if you put 30 back into the equation like the big crazy t-charts that we did in our first polar graph videos. If you take that 30 and you put it back in here, you're going to have a -4 times the sine of 90. So it's going to get us back to this idea. And in fact, that's what I'm going to do on this next spot here. So we're going to take this 30 and we're going to show how this works. So we're going to take this 30, it's going to come up here. So my first theta value should be 30 degrees. So now I can plug that in, 30 degrees, and I can evaluate that. I know that sine of 3 times 30 is really sine of 90. So that actually equals a nice 1. So this is going to be a -4. So the first point that I plot, remember our points are always in the form r theta. Our first r value is -4. Our first theta value is 30 degrees. And now we're back to what we did at the very beginning of the chapter in learning how to plot our points. So we're going to count a -4. 1, 2, 3, 4, and then we're going to rotate our 30 degrees. So our first point is going to be 1, 2, 3, I got to recount it, sorry about that, is going to be right here. This is our first point. Once I have that point, now I can just start counting those 120 degrees because the tips should be 120 degrees apart. So then I can follow that around and I can get my next one right here. And then my last one, if I rotate 120 degrees, I got to recount 1, 2, 3, 4. Sorry, guys. Okay, there we go. Those are where the tips of all the roses are going to be, all the petals. And then we can just draw those petals in. And I'm pretty generous if you just make your petals look kind of reasonable there. I'm more interested in learning that, having that rotation be correct. Okay, the last one we're going to look at is going then to be our lemniscate, okay? And again, I know this is a lemniscate because of this r squared. That's my big clue. And all I really need to know is that it's cosine, so it's going to be along the polar axis. And then the 9 is not the length of the petal. The 9 is going to be the length of the petal squared, so it's actually only going to have a petal length of 3. So 1, 2, 3, and I'm going to go 1, 2, 3, and that's going to be my lemniscate. And all the cosine lemniscates will be oriented along that polar axis just like that. Okay, so that's all we've got in terms of roses and lemniscates, and then we're all done with our polar graphs.